for this evening. Really excited to be here chatting with you all. My name is Laura Mateka. I'm on the talent acquisition team here at Slalom Build, and we are super excited to do an introduction to GraphQL with you all. So tonight we're gonna do a little introduction, meet those of us here from Slalom Build who are going to present to you. I'll also tell you a little bit about us in case you don't know who we are and what we do as a company. We'll give you a brief high-level overview of our internship program, since I'm sure that is top of mind for a lot of you. And then we'll dive into the tech talk, and we'll leave a little bit of time at the end for some Q&A. So as I said, my name is Laura Mateka. I'm a talent acquisition manager here at Slalom Build. I've been with us for 2 years now. I come from a technical recruiting background prior to joining Slalom Build, where I worked with everything from small mom and pop type companies all the way to Fortune 50 companies. Hired everything across the technology spectrum. And then I was brought in 2 years ago to head up the growth of our machine learning and artificial intelligence team. I also act as a utility player for us, so I support a lot of areas of our business. I support DevOps and data engineering and software engineering, solution ownership, just about everything that we use to create our build teams. And I support everything from our internship program, early career hires, all the way up to our director plus hires. So I have covered just about every area of our business that you can imagine. That's a little bit about me and my journey. Michael, I'll let you go ahead and introduce yourself.
Thanks. So I'm Mike Hawley, a senior software architect. I've been with Slalom 5 years tomorrow, actually, and am a Northeastern graduate myself. So happy to be here to do the this tech talk with you all. Tori, you want to introduce yourself?
All right. Hi, I'm Victoria Hayes. I've been with Slalom for a little over 2 years, but I was also a 2017 intern, and I'm part of the engineering practice. Karvi?
Yeah. Hey, everyone. I'm Karvi Panchamya. I'm a data engineer at Slalom, and I've been for around 3 years and a couple more months. Essentially, just what I do on a high level is just work with a lot of data, create data pipelines for different companies, and we help drive the business decisions. Happy to be here, and yeah, hope you guys enjoy the talk.
Thanks, everyone. So I'm sure many of you are wondering, what is Slalom Build? In the simplest terms, we are the original build as a service firm. So what is build as a service? I have a fun video that I will show you that does a great job of illustrating and explaining the new area of build as a service as we have coined it. But in the most raw form, we focus on creating custom built software and data products for companies. And a lot of the work that we do really helps organizations unlock the potential of technology for their business. So we, as build teams, work to design, develop, test, release, and scale digital products and data experiences. We do so in a flexible, collaborative, and repeatable methodology, what we call our product engineering methodology. And these solutions that we craft really help organizations on their digital transformation journey. We also help them elevate their own capabilities within their organizations that allow them to really drive an impact now as well as in the future once we have finished our solutions with them. Here is a little video.
These days, nearly every company is a technology company, or they better become one soon, even yours. And businesses that embrace this kind of thinking will stand apart, but like everything make or break, a change like this brings new complications, new obstacles, like finding the right talent and just keeping up with the pace of innovation and customer expectations of quality and speed that are, let's just say, challenging. Build as a Service helps organizations clear the hurdles, providing the ability to not only compete, but lead. Built on the as a Service model, BaaS is your seamless access to the right expertise, working in teams to rapidly create and deliver. Totally flexible, totally scalable, and absolutely predictable. Build as a Service is that always ready, instantly available engine that helps you craft custom-built modern software, the software your business runs on, and the products and experiences your customers love, all while harnessing the data that helps you see around corners, so you always know what's coming. You could say that Build as a Service is all about closing the distance between concept and creation, ideation and revolution, now and next. And it'll help you build your future today.
And I wanted to give you a high-level overview as well around our internship program. I think that one thing that makes our internship program really unique is that it mirrors exactly what our builders do every day. So we combine internship teams to reflect our normal build product development teams. We have you co-build side by side with our actual builders. So in a non-COVID, non-virtual world, what that means is you're sitting in our offices with our teams and seeing how we deliver our work. And you are working on a 10-week program to build a software or technology solution for either our internal teams or for our external clients as well. So you get to see what we do, where we do it. Who you work with is a cross-disciplinary team of other interns. So you are getting to experience the day in life of our normal builders, where you're combining software engineers with data engineers and DevOps engineers, some front-end experience designers. We have our solution ownership role, which acts as a blend of product management, project management, business analyst. And you get to experience our product engineering methodology, which is our approach to Agile. So what we love about this is that it not only gives you a very real feel of what our normal day-to-day is like for our full-time employees, but you also get to really own creating a custom solution from scratch. And you get to do that with a team of interns, not only in the Build Center location that you're interning in, but also with a team of interns in another location. So this year, our Boston interns got to team up with our Charlotte interns. The year before, our Boston interns got to team up with our Toronto interns. So how does that actually map out? We have our internship program in 8 Build Center locations. Like I said, we combine 2 locations together. So that means 4 internship product teams. You can see on the bottom right corner of this slide what the teaming was for this past year. And then on the bottom left corner, you can actually see how that mapped out in terms of a product pod. So I kind of broke down those roles already for you, but you can see what it looks like when you combine 2 intern team locations. And how that mapped out for us in terms of size this past year was 51 interns that we had across these 8 locations. And to give you a sense of how competitive our internship program is, in Boston alone, we had over 800 applicants for this past year's internship program. So it is becoming very popular, which is exciting for us. But one thing I always want to say is we try to give preference to people that are already located in the city of the Build Center that they're applying to. So of course, those in Boston are going to get our top priority. And we actually had a high number of interns this past year from Northeastern. I want to say 4 of our interns in Boston this year were from Northeastern. So we have a great track record of hiring interns from Northeastern University. I think that shows the great prep you all get in your curriculum. And the hiring process for our internship program also matches our normal hiring process for full-time employees. So what we do for our internship program over the 10 weeks is we start April to August actually figuring out what we're going to do. Week 1, you start sprint 0, and then weeks 2 to 9, we operate in 4 2-week sprint cycles. And then in week 10, you actually hand off that solution to our internal teams, and you get to present to the entire build organization on the project that you worked on. So that's a little bit about our internship program, a little bit about us. Happy to answer any questions you all have. But we can save that for the end. I'm going to hand it over now to Tori and Mike to dive into the presentation.
Thanks. So I'm going to start us off and just give a little introduction here to, so this is our agenda. We're going to quickly cover what is an API, a little bit about REST APIs, which is, I would say, the last decade or so has kind of been the standard web API. So a lot of you have probably seen this, so we'll touch on that quickly. And then we're going to get into GraphQL APIs and talk about what they are, how they're different, some advantages that they have, and look at a small example of how a weather website might use both REST and GraphQL. All right, so this is just a quick slide on what an API is. So application programming interface. So I'm assuming most of us have used this to some level. So if you've done a project where you plug into Twitter or Twilio or Facebook or anything to read their data and pull it into your app, you've used an API, likely REST, but a lot of the big names now do have GraphQL APIs. And so I think GitHub is another big name that in the last year or two came out with a GraphQL API. But we even see APIs in programming languages. So for example, when you call a print function, that's using that programming language API, and then that calls some operating system API, and essentially you end up with this connected stream of APIs. And yeah, so they're everywhere. But we're going to focus mostly on web APIs today. So on the next slide, we take a quick look at REST APIs. Yep. So there's a really, we'll send out this deck afterwards. There's a really good open source ebook called Consumer-Centric API Design. And that lays out what you should look for in a good API and gives you some pointers if you're designing them yourself. So one of the important things about a REST API is that it uses HTTP verbs, and it helps make it plain English in a way. So if you're reading data, you're using the get verb. If you're deleting data, you're using the delete verb. And then post is for create and put is to update. Some of the good things about REST APIs that they're pretty easy to cache. So say an API that doesn't get updated very often, if you make the same call over and over again, you're going to get the same data back. So from the server side, it's really easy to take the data from the database, read it, and save it in a cache, and then return that. So you get some nice things like fast speed, less hitting of the database layer. So I would definitely recommend, if you're not familiar, check out the consumer-centric API design. And we have a couple of examples. If we go to the next slide, I believe it's what a Git look like. So in this example, we'd be doing a HTTP GET to, this is just api.example.org, and we're getting a user and ID of 12. So when you're designing the REST API, you typically don't want to use verbs in the URL. that the path is defining the type of object you're getting. So in this case, we're getting a user back. We have what the SQL, so our database query, what that would look like. It's just checking for a user ID that matches that ID of 12. And then on the right is the response body that we're getting back. So notice in this case in REST, you hit your endpoint, and then the data you get back is preset on the server already. So we just said we want a user of ID 12, and you can see we're getting a name, an age, an email, and a description. So it just gives us whatever the server says. So if you used a REST API before, you probably had some kind of documentation that was paired with it. And this documentation is really required, I would say, to be able to use an API successfully. You can try hitting the API and seeing what you get back, but every good API, REST API, should have documentation with it. And then the next slide is just an example of a post, so creating. So you can see in this case, we're doing a post to v1 animal and animals GUR and animal type. So in this case, we're sending some JSON data and we get a response back in JSON again, not too different from the first example. Okay, so if we were to look at how a weather website might use REST, unfortunately some of the colors didn't show, but so I have just a quick example here. So we can see a couple different data sources. So for example, we have the almanac, we have some news right here about the hurricane, and we have astronomy below. So theoretically, these could be coming from a bunch of different resources or different APIs. So I think if you click 2 or 3 times more, they should get highlighted. Yeah, okay. So this is just showing that data is coming from 3 unique sources, and the endpoints over on the left is where you might get them from. And oftentimes when building a web application, when you're designing the UI doesn't map directly to a single REST endpoint. So you might have to make multiple calls. And this is a little troublesome because then the website code, so your client, has to handle all this state and say like the red and the blue call might be successful and the green isn't. So now you need to handle that failure, and you end up in some weird situations. So yeah, if we go to the next slide, we'll introduce GraphQL, which is a REST API alternative. And it's really a query language, and how you define it is with a schema. So I believe Tori is going to show a schema at some point during her part. And one of the big advantages about GraphQL is how I mentioned before with REST, you need to have some kind of documentation. And there are tools to help you with documentation when building a REST API, but you still have to write some additional decorators or comments yourself, which turns into that documentation. But for GraphQL, when you define the schema, that becomes your documentation. And the schema is a JSON-like structure. So that defines all the operations you can perform and the types of the fields that come back. So we'll take a look at that later, and I think that'll be a little clearer. And this concept of a GraphQL operation is one of 2 types. So a query is for fetching data, and a mutation is for any kind of operation that mutates data. So it would be equivalent to either a post, a put, or a delete. And the one good thing is you also ask for exactly what you want. So in the last example, I mentioned we were calling 3 different endpoints because the design team decided, this is the information we need. With GraphQL, if they decided that, it would just be a single endpoint. So I think the next slide, we have a couple examples. So this is equivalent to the REST GET. So this is a query. So you can see here where over on the left is the GraphQL query. So we're saying we want to get a hero, and for each hero, get the name, and then for each hero, get their friends and the friend's name. So the response on the right keeps a similar shape to what we asked for. So we can see hero, name, friends, and then the name of the 2 friends. And then the next slide shows so this is the same weather website example. So if we were getting the same data for the news, the almanac, and the astronomy, we would now just have a single request. So if you click ahead, it'll just one big green. So the box again represents a single HTTP request. So in this case, you can see we're running a query, and we're passing in, I just put Boston zip code, that you can pass in a parameter into a query, and then we're defining the data that we get back. So in this case, we're saying, give us news stories for this zip code, along with image URL, URI, title, astronomy times, and so on and so forth. So now this is really simple because you're doing a single request and you're only getting the data you want back. And one way people have done this with REST is something called backend for front end, which you would have this middle layer. So before, when I showed you had the 3 unique endpoints, what they would do is in this middle layer, call those 3, put it into a new JSON format, and then you have a single endpoint that's linked directly. So you have an endpoint that's tightly coupled to a specific web page. But in this case, what we see here is we can avoid that type coupling, but still have something that's very specific to a given web page. And I think we'll see shortly here. Tori's gonna continue with this and show you more about GraphQL and how that all works, and we'll see some live in action.
Okay, thank you, Mike. So the main metaphor I like to use with distinguishing the REST versus the GraphQL is kind of like at a sandwich shop, where REST is like you just kind of go to the counter and pick up a random sandwich. And then when you have it, you're probably picking off onions, adding mayo, stuff like that. Versus GraphQL, it's a lot more like a Subway, or if you're getting a burrito, Chipotle, where you're there picking each ingredient as you go. So GraphQL is the same way. Laura, can you give me the next slide? And the way you know what's available for you to order is in the schema. So the schema is required for every GraphQL project. Often it's a bit of the source for the code. So some programming methodologies for it will have you write a schema and then it will generate code for that schema. Others, it's vice versa, where you write code and it'll generate the schema for you. But this is a defining feature because it's hard to make orders without knowing what's on the menu. So at the link here, I will copy and paste that URL so you can explore it in your free time. This is a GraphQL Explorer where there is a movie API that's being exposed, and in it you can enter your values by searching through the query in the documentation explorer. And this is basically a nicer way to read the schema. Okay. And so in the examples here, you can see that we have a higher level entry of query, which, as Michael pointed out, is equivalent basically to a REST GET. And then from that query, there is a find, a movies list, a people list, a search, a trending, and a TV. And you can do any combination of these as you go through the properties. You can select the properties from the objects. So if you're getting movies, you may want only the title, for example, so you can do that. Next slide, please. Okay. So with filtering, one thing you might note in the schema is that sometimes you will see parentheses being offered, much because it's being called very similarly to how a function's being called. So the you'll notice that if you've seen JSON before, the schema looks very similar to JSON. So it's a lot of the schema stuff tries to imitate traditional functional calls. So if there's a function that exists to be called, you can call the function name and then pass the parameters. Most of the time, the parameters are optional. Unless the only way that the way to tell if it's required is if there's an exclamation point after the field. So you can, yeah. And that is the standard there. Obviously, if there's an object type specified in for the parameter, you would give it an object list format, and the structure is the property name, colon, the value. Next slide, please. Okay. Another thing to note with GraphQL is that first off, when we want to do pagination, which pagination is a common thing where if you're trying to break down the large sets of data and just serve a small amount at a time, the most common method is to just say that I want values 1 through 10. So you start at 0, go from 10, and it's based off of the indexes. And this is great if you want to go to a specific page at any given time, and you know that your values aren't going to change too much. So that's one method. Another method that I see a lot in GraphQL I want to make note of is cursor-based offset browsing. So what the pagination with cursor-based is instead of relying entirely on the indexes, because indexes can change based off if it's a numerical thing and people input more values, they'll create like a pointer. So if you have worked with like a linked list or whatever, you'll know that the pointer points to a address of memory as opposed to being a hard-coded value. And this way it can just automatically go, hey, I was at this gibberish index value and I want to get only values after that. So you can, so the GraphQL server knows to look for that particular pointer value and return the rest. Another thing that's very common to see in GraphQL is that there's wrappers around objects. This is because the object structures are very consistent. So if you have a movie object, the movie would be the node, which is the item within the pointer. And then the cursor is the ID of the pointer. And then edges is the wrapper around the cursor node thing. And a total count is part of the reason why they have it stretched out, because technically all you want from the movie search list is a list of movies, but you want a total count to know where you're at comparatively. So that you'll see that a lot if you dig through a schema. Laura, I'm going to steal the screen a little bit because the next part is going to go over some methods for developing your own GraphQL and just showing off the GraphQL documentation.
You should have the ability to take over.
Host disabled attendees share screen sharing.
Okay, I think I should just need to make you host. I think I just forgot to. Oh wait, Emma, could you do that because you're host now? Just make Tori co-host, and you should be able to do everything from here on out.
Okay, thank you very much. Sorry for that.
No worries.
Okay. So here's that schema I mentioned earlier to help bring each perspective because the size is a little small. And we can see our pagination friend where after the entry with this value, SUI, kind of gibberishy, it returns the first 10 values after it. It returns total count, the edges, which is basically the list of indexes. The key changed. So we'll drop this entry real quick. Hit enter. And then you can grab the key to get the values after it. If I remember to copy paste correctly. So see that these are all the values that aren't included in the previous ones because it's after the last entry of the previous set. And we found these by starting with movies, and then we see that movies object can be clickable here. And we're looking at popular, so we see that popular has the options of after, last, before, and int, before and first. And so when we input first, which is an int, and after, which is the pointer string, we then have to go through the object structure. So movie edge is edges, which is basically the entry values. And within the entry values, you have the cursor, which is the pointer, the node, which is the value itself. And then we can pick our fields from there. Okay.
So what would it look like if we wanted to query some more fields?
So
in
if
a
you
movie?
So if you wanted to get more things, such as like the overview, you would just slap it into the object here. It's definitely a lot easier when you're working with less nested objects, since you don't have to keep track of your edges and cursors. For example, here I have a really simple schema here, where all it is books and authors. So you can see you have the query type being defined, the type of book being defined, and the type of author being defined. So you'd only have to ask for the immediate properties without having to try to memorize the whole thing. Okay.
And what happens if you do type a field that doesn't exist?
So it returns an error at this level. You'll note that it doesn't normally give an error code. GraphQL does not care about error codes. Almost everything's a 200 success. Instead, you get an errors object, which can then be parsed. It's also important to note that if you have a query that mostly works, but has an error partway through, so let's say you want to do a filter on a certain value, but that value you give is greater than the total number you have, instead of giving a full error, it will return to you as much as it can, and then it will just have an error message beside the data response. Okay. And all of this can be seen at on the GraphQL official website, which is graphql.org. And if you ever want to try developing it, it's very friendly for finding where to start. So if you just go under code, it'll give you your list of libraries to work with. Personally, I've worked with Hot Chocolate, which is a very automatic version of it, where you do a lot of coding up front and it automatically generates things. And another common one is for JavaScript and Node. We'll have GraphQL JS and Express GraphQL. And I've heard you guys work in Java, so GraphQL Java is fairly simple. And it just works off of a typical Spring Boot project. So it's auto wires up just fine and develops off of the schema that you give it. I think I will let off there. So any questions?
So,
Sorry. You can go.
oh wait, is someone else speaking? You guys can go. It's just like hard to raise your hand if you're a co-host.
Oh, that was just me, Angelina. I had a quick question about like edges and nodes. Is that just something for organization? Like if you have a lot of different data, that you would put it inside a node, or like why would you use edges and nodes as opposed to just listing out all your fields?
Yeah. Do you want to take it, Tori, or do you want me to go?
Sure. The edges and nodes is really more for cursor-based pagination versus an index-based. So they need something to pass the external values to the movie along without necessarily forcing it to be involved, since the pointers may not always be the same based off of the particular cache values. So instead of forcing it to be involved with the more static movie object, it's just attached beside it. If it's only an index-based browser where it's first and then limit 10, then you wouldn't need to worry about it as much, since it could be a more simpler model that way. Do you have anything to add, Mike?
No, I think that's exactly it. So you can pass both that total count and the cursor offset, because otherwise there'd be nowhere to send that information. And that's pretty standard. So it's actually called a connection in GraphQL. So anything where you have a relationship and you have two separate objects, that's considered a connection rather than just a type, like we've seen otherwhere. Like the book was defined as a type, and the connections typically have the edges and the nodes.
Cool, thanks.
You all can feel free to chat in your questions as well. Carvey and I, we can keep an eye on the chat for any questions and relay it to Tori and Mike to answer.
I actually had a question. So I use API requests like all the time in my own projects at my co-op. And so I know that when I am making an API request, I usually use like Axios to make the call, and then that's how I kind of get the information back. So how would we use, is GraphQL like the same thing, and how would you exactly use it?
Yeah. So I think Tori is pulling up here, but it's every GraphQL request is via post, an HTTP post. So if you wanted, you still could use Axios or another HTTP library or HTTP library and make the requests. But really, to get some of the niceties from using GraphQL, there are a couple libraries. So Apollo client is one. There's also Relay. There are a couple other popular ones, but there are ones that make it really easy to make requests, and a lot that the post is abstracted away from you, and it gives you like out of the box client side caching. You get, when you're generating the GraphQL, it's something similar to like what Tori had up in the playground. So you get auto completion. If you say have a typo in a field name, it'll highlight it for you and let you know that it doesn't exist in the schema. So I highly recommend looking at Apollo or Relay as a client if you're going to use GraphQL.
Great, thank you.
Yeah. What front end do you use? Angular or React or something? Some other framework?
Yeah, mostly like React. If I'm making like some script and I'm just trying to access an API, then like JavaScript. But yeah.
Okay. Yeah, because I think Apollo, if you're using Angular, Apollo's the one with the best support. But if you're using React, you have a whole slew of choices. Yeah, so that's the site. And Apollo has a server and a client. So the server is based off of Express and wraps the Express GraphQL. And then there's Apollo client, which is for generating your web app. Any other questions?
So, could you kind of go over again what the like benefit was to using like GraphQL versus like REST APIs? I'm not sure like I totally understand. I think the main idea I got from it was that you basically don't have like 3 distinct endpoints where all of them could fail, but like one instead. But I'm not sure if that's actually like a good conceptualization of what GraphQL actually does.
Yeah, there are a couple things. I'll give you some of my favorites, and then maybe Tori can add in a couple of hers. So I'll start actually going back to like who created it. So Facebook had created this, and it was largely for their mobile applications. So they found they were greatly overfetching data, because what happens a lot of times with the application, it starts with a simple, well-defined REST API, and then it continues to grow, and you end up with these dot objects, they're called. So you would call get user, and like on your first page, maybe you just have your username and email, but then you want to show post. So now user has post, and then you want to show people who have liked the post. So now your user has post and then likes, and then like you can see it just grows and grows. And now all of a sudden you're calling get user and you're pulling in 5 megabytes, and you're really only showing like 4 text fields of the 5 megabytes. So it's completely overkill. And Facebook found, especially on mobile, you don't want to be pulling in extra data, because that's making the response time from requesting the page to loading a lot slower. So they came up with this, where you ask for it, what you want, and you get exactly that back. So that's one advantage for like smaller apps. When you're starting out, though, that's maybe not enough to choose GraphQL on its own. The spot where I really think it shines is developer tools. So like I said, like this tool Graphical here, you're able to fully explore an API and like quickly type out queries and mutations and run them and see what the response is. And then there are a lot of tools. So ESLint, which is a popular linter for JavaScript projects, has a ton of rules around creating GraphQL queries. So like I said, you're able to read the schema, and then as you're creating your query, you know if it's valid right away. And you also get type safety. So the issue with like a REST API, you need to read some documentation or actually make the call to see if something's a number, or to see if it's a string, to see if it's nullable or able to be undefined. But with GraphQL, you get that type safety right away. And actually, because you have that type safety, there are libraries you can import the schema, and it will automatically generate TypeScript types for you. So I found just using it has helped reduce bugs, and generally as a developer has been a super pleasant experience.
Right. So in a way, the schema, because I was a little confused about that as well. But the schema is like kind of the way it would be in like any relational database. where you'd have like really clearly defined like attributes and types, and you're just querying all those attributes, but in just a very different query structure.
Yeah. Yeah. So like what Tori has up here, like you can see, you can browse the schema and see, so you can see every query you can make, and then all of the response types and all the fields in those types. And then the same, if there were mutations, you can do the same and browse it all. And you can actually, there's GraphQL supports introspection. So you can run a specific query and it will return the schema to you. So really, like once you have your GraphQL API up, any person can run that introspection query and get the schema and load it into whatever tool they want, and then it's fully browsable.
Thanks.
What would you say, Tori? What was your experience? I haven't used any kind of, because you use, I think Hot Chocolate, you said, uses annotations and things to auto generate.
Yeah, I mean, my personal favorite thing with Hot Chocolate was most of the time you were, instead of writing out like all of your manual pagination features, you could literally just do @use paging and would automatically set up cursor-based pagination for you. Or if you wanted to have a filter, you would just type use filtering and it would go into the properties and automatically go, okay, name is a string here. So they could be looking at, so they might want a regex, they might want a substring from the front, they might want a substring from the back. And it would just generate every single permutation of possible filter, and it just listed it out for you. You could combine the filters and it was just magical. Like I'm kind of broken from using any other type of GraphQL just because it was so automatic. So look, tools like that are definitely very neat. But it also kind of changes the way you think about the code, because when you're doing it automatic like that, the places where you would cache the code normally is different, because instead of you controlling where that filter is happening, there is a middleware that is handling all of that logic for you, so that you would cache your entire database basically, instead of having the database call be determined by the API call, which is it's a different way of thinking.
Yeah, and one last thing, I think it does make traversing relationships very easy. So in this case, it's up on the screen now. We have this type of book that has 4 fields, and the first 3 are primitive. So ID is essentially just an alias for a string. So that on line 6 there, name's a string, and page count is an int. But then author is of actual type author that we see down below. And say, like, if we add a line there, Tori, like after 15, we could add something called books, and then that would be of an array of book. So you could create a query where you're looking for a specific book by ID, and then you get the author, and then on that author, you get a list of all their books, which might be something you want to display on a page, right? You're looking at a book, you want to know the author, and you want to see their other books because you might be interested in them. So like right there, you're traversing down and then back up and then down again, and that it becomes very easy to do. And then because otherwise, if it's a REST API, you're back to making those multiple calls, or you're doing what I mentioned, that back end for front end, where you're creating a specific endpoint just for that one view. With this idea, like if you build a GraphQL API well, then there's really no coupling from view to API. And any other questions? We can happy to share experiences, clarify anything, or if you want to see the playground again. Has anyone used GraphQL before? No.
This is really cool though. I feel like at like I've been using like regular REST APIs for a while now, and I feel like I'm often either getting tons of data back that I don't actually need, or I'm creating new endpoint. Like if I'm making my own API, I'm like making new endpoints for very specific cases. So I feel like this is really cool
Yeah.
and really helpful. I guess like the tricky part would be actually creating a like a good schema and like a good system for the GraphQL.
Mm-hmm. Yeah, I actually find when thinking about creating the schema, I think it's easiest to think about the data from the view of the user or like end user. Because sometimes I feel like REST abstractions err more towards like an engineering mindset, where in this case, like if we're looking at this, right, it kind of just makes sense. Like you expect a book to have an ID, a name, a page count, and an author, and that relationship to be there. So I think kind of like taking off the engineering hat and putting on a designer hat, like approach it more from that view has been helpful. And we didn't look too much at mutations, but actually, so I mentioned when designing REST APIs, it's generally considered poor practice to have a verb in your URL, that the verb is meant to be the HTTP verb. But in GraphQL, you typically do use verbs in mutations. So yeah, exactly what Tori has typed out here. So you would have a mutation called add book, and you would pass some input in. Or if you're creating, say in the case of Facebook, that you're liking a post, your actual mutation would be called like post, and then you say you would give it the post ID. So I think thinking of mutations as distinct actions that a user makes is a good way to think about implementing them. Yeah, and as Tori showing, there's a mutation typically has its own type and has a suffix input on it. So in this case, when you're adding a book, you're using a book input type.
Okay. And also inputs will be anything that is generally within the parentheses versus a type is anything outside the parentheses. It's a very pretty easy way to help read the schema.
Yeah, I would recommend this. Is it graphql.org? I think is their website. They have a pretty good learn section that walks you through, and I think it uses Star Wars as an example, maybe.
Yeah, I believe it's
Yeah.
Star Wars API. And obviously right here you have our queries and mutations.
Yeah, so you'll find a few, yeah, so definitely like check out the playground at your own leisure. It's a good way to get a feel for building queries. And so Tori has the link to the one. You'll also find there are Star Wars movies, Pokemon. I forget what else. There are like 3 popular ones that everyone creates. So check them out and build some queries and get a feel for it. Yeah, there are a whole bunch. Any other questions? Okay.
All right, well, it's almost 8 o'clock anyway, so I think we can wrap up if no one has any more questions. So I hope you guys enjoyed that talk. I personally found it very interesting because I don't know a ton about either REST APIs or GraphQL. And yeah, it was just exciting for me. So I hope you guys enjoyed it as much as I did. But yeah, you're dismissed. Have a good night.
Thanks, everyone.
Yeah, thank you.